Okay, so we have a system of equations and we're going to use this new method to solve it using the inverse. So first we pull off the coefficient matrix, 3, 8, 4, 11. We have the variable matrix, x, y. And then we have it equaling the constant matrix, 5, 7. Now, this is the A, this is the x, this is the b. The goal is to get the inverse of A. And I probably have that written in my way. But that's what we have to do. Okay, so we have to find the inverse. That's what we've been working on. We're going to use that handy formula. So let's see. Yeah, AD minus BC times, and then D and A switch, and the opposite of negative B and C. And that's, remember, that's based on A equaling A, B, C, D. I should have written that first. That's part of the formula. Okay, but we have our, numbers, and we can just put those in. So our A inverse is going to be 1 over 3 times 11 minus 8 times 4. And then the matrix part is going to be 11, and then the 3 is going to be down here, and then it's going to be negative 8 and negative 4. Okay, so we get 1 over 33 minus 32 is 1, so we don't really need the 1 times whatever, it's a scalar, So A inverse is equal to, I'm going to put it in orange so you can see it when I move it over, 11, negative 8, negative 4, 3. Now we showed other ways to find the inverse, so you could use one of those methods as well, the augmentation method, or I guess the algebra method. Anyway, okay, so now what happens? We're going to take that inverse and we're going to put it right here. And then we're going to write the rest of the equation. The left-hand side. Now, we have to write the inverse again. So what are we really doing? We're multiplying both sides of this equation right here. We're multiplying both sides by A inverse. So it's kind of visual. Hopefully you can see it. It's kind of hard when they get bigger, but that's what we have. Now, what do we know is going to happen right here? That's going to turn into the identity matrix, but it's not a bad idea to check it. So you would have 11 times 3, let's see, I'm taking this row times this column, minus 8 times 4, and then I'd take 11 times 8 minus 8 times 11, so I'm doing this one, and then I would take the bottom row times the second row times the first column, so negative 4 times 3 plus 3 times 4, and then I'd take the second row times the second column, which would be negative 4 times 8 plus 3 times 11. Okay. Put that back in. Okay, now finish off the equation. Let's just write x, y equals, and we know what's going to happen here. This is going to be 33 minus 32, which is going to be 1. And this is going to be 88 minus 88, which is 0. And this is going to be negative 12 plus 12, which is 0. And negative 32 and 33, which is going to be 1. This turned into the identity matrix. So we get just xy. Now, I have to do the multiplication here. So what's 11 negative 8 times 5, 7. I'm going to do that first row times that one column that we have. Okay, so that's going to be, I've been doing it in orange, so 11 times 5 minus 8 times 7. I don't know what that is, but I'm going to figure it out in a minute. Okay. And then what's negative 4, 3 times 5, 7. So negative 4 times 5 plus 3 times 7. And then we're going to have to actually figure out those calculations. So we could use a calculator. Okay, let me go back here. So 55 minus 56, negative 1. And then negative 20 plus 21, which is 1. Okay, so not super exciting there with the numbers, but negative 1 and 1. That means x equals negative 1 and y equals 1. As an ordered pair, you could write negative 1, 1. That would be the solution then to that system. Okay?